Today's guest is my co-founder and our CTO here at Firestorm, Ian Muceus. Ian has a background in both aerospace, software startups, and additive manufacturing. And that holy trinity allows him to really think through really, really complex problems and attack them at different angles. I think you're going to enjoy today's conversation as we talk about everything from how you process and learn new information to what's right and what's wrong with the DOW today. Ian, thank you for joining us today.
Of course.
Ian is co-founder and CTO of Firestorm with me. So we're keeping this one in the family. Why don't you tell everyone a little bit about yourself?
Yeah. So background in aerospace, went to Cal Poly SLO, was lucky to study under some awesome professors. Bruce Wright came to us my senior year, father of the F-22, got to do my senior project under him. So that was really rad.
Yeah.
I had a childhood kind of doing things like rocketry, robotics through high school. So it was kind of natural progression to go into aerospace. My grandfather was an aerospace engineer, worked on the P-51 and stuff through like World War II. So didn't mean for that, but I actually found that out later. So it's pretty interesting.
In your blood.
In our blood. And then, after that, I kind of got out of school in 2010. Hard time to get out. Jobs market was crap, and went to Booz Allen. Luckily had some connections there. Was able to work on a number of different projects at Booz Allen with different customers, DoD, DHS.
Were you in California or did you?
That was DC.
You moved to DC. Cool.
Yeah, so that was went straight from Central Coast of California to DC, which was took some getting used to. From flip flops and board shorts to a suit every day.
It's the worst.
It is the worst. Yeah, it's not fun going over there. And it was interesting, like getting used to how that whole machine works and understanding how you need to like play in that environment, but also maybe what you don't want to do with your life every day. It's good for certain people, of course. And then really got into software startups after that. After kind of the grinding slowness of the government and those gears, I wanted to get into something that was the antithesis of that, which was startup space and software startups. So first did my let me go kind of do good for the world type thing, which was O-Power doing energy efficiency at scale, big data play. Got acquired by Oracle, IPO'd and then got acquired by Oracle. And then went to Segment, which was another big data play, customer data hub. These were new things about centralizing data, being able to play it into other tools really rapidly. Loved it, but as far as software plays, what I got kind of complacent or felt complacent in is like you play those playbooks once and you perfect them and it's great. And this is why, investors love software. It's super easy. Once you have that playbook, they did amazing. I think a year or two after I got out, where it was acquired by Twilio for like $3.4 billion. So massive exit. And then really got back into I say, my love of additive. My first, intro to additive was making wind tunnel models, and stuff in school. And then I had the opportunity to go to work for a DLP startup in the Bay Area called Origin, which was doing digital light processing, 3D printing. So photopolymers, really fast, high detail, and really scratch that itch of like, let me get back into making real things out of the software world, but in that nexus kind of between software and hardware.
Explain to people what DLP is and why it's like pretty cool technology.
Yeah, DLP uses effectively projectors. So it uses like a UV projector at the usually 385 or 405 nanometer wavelength, excites the polymer chain reaction for photopolymers. So these are thermoset materials. Why that's interesting is basically with a dwell time of that projector shining a cross-sectional area, so layer by layer, of about call it 3 to 12 seconds. That's your entire layer. So as many you can array projectors, you can have a single projector, you can have higher, lower detail based on your pixel size. But it's extremely fast and allows you to work actually across a lot of a wide range of materials. So really high variety. And we created kind of an open ecosystem for material partners to build on our reaction engine. So that was our printer. So we invited the likes of BASF and Henkel and different folks into the fold, and they built materials for us. So we were just kind of the printer. They created materials. They actually pushed materials through us. So we got good discounts on materials. All these things was really beneficial for the end customer. And then we worked really heavily on application development. And for me, that was pretty much entirely defense and aerospace, because didn't really care about teeth and stuff. Wasn't interesting to me.
You have beautiful teeth, so you don't need to care about them, right?
Sure, yeah.
No, so tell us a little bit about like what were some of the applications that were in the aerospace or defense play for your printers?
Yeah, I mean, they were so broad. I mean, it was everywhere from like interior paneling for like passenger aircraft, which is like the hardest thing in the world to do because there's massive compliance, that you have to work with.
Yep.
You have to have flame retardant materials. We actually, with Henkel and a company called Molecule that they acquired, developed the first flame-resistant UL94V0 material that could be used internal to cabins. Now, we never really got any across the finish line because in my time there, or since I think at Stratasys, who acquired Origin, because that process takes forever. You think the auto industry is really slow at adopting new things, like, Aero is worse. Auto, they say like 5 years to get something into prod that's like new and qualified. Aero is probably 10 to 20 sometimes, especially on the passenger side.
Do you think it should be that long?
I think for the right parts, it should be, but across the board, definitely not. If you're putting a cup holder, which is a famous thing in additive, in like a B2, and you're printing that, on FDM, and it was some airman's side hustle project that they did, like, should that have to be qualified, to UL94V0? Like, no, there needs to be exceptions to the rule for certain things.
Right.
And the way that they look at it sometimes is on the bulk weight of material that you're putting into something. And then what is how can that combust and then lead to like VOCs that could like knock the pilot out? Like those are the worries, right?
Yep.
Or passengers, obviously. And now though, we're in the drone world, right? Like, do we really need to worry about those exact same problems? So there need to be different sets of rules for different areas. And there are in many cases, but a lot of times you are in these situations where there are like these archaic rules that haven't evolved with the times and they need to evolve a little bit faster.
How much of a problem do you think that is for just broader DOW and then MODs around the world?
Yeah. Well, I'd say the biggest problem that we faced was, we'd be able to produce a replacement part for something that was on a 1970s drawing that had to be made with some sort of a composite layup process, yada, yada. That line's dead. Now to reinvigorate that line or to turn it back on for like a Honeywell, we worked with different customers. It was so expensive. And you always hear these like the $10,000 hammer, et cetera, right? Many of these applications that end up being that expensive are because the line just doesn't exist anymore. The customer went out of business. There was consolidation. They haven't had to produce them because now it's a new problem. We did a stator cover for a electric motor, and we could produce them for like, I don't know, it was like 17 cents and each. And they were going to turn a line on for like, tens of thousands, if not hundreds of thousands of dollars for that part that we could make for 17 cents.
Right.
And it's crazy. And it's because no one wants to sign on to the risk of changing that engineering drawing or the like labor, et cetera, to change that. So they're just like, we'll stick to what we know. We'll spend a ton of money so we don't have to do some upfront work. And I think that's a problem.
Okay. So we'll come back to that and double tap on in a second. Talk to us a little bit about what you learned during COVID. This is one of the most interesting things about how you deployed advanced manufacturing.
So we, as everyone, right? Like we were in the Bay, and we were at that time we tried to get on to basically, like being a what did they call it? Like a preferred company
vendor.
that could like be operating during the pandemic, as everyone did, right? The way that we did that is we leaned into manufacturing nasopharyngeal swabs on our printer, spooled up a whole kind of manufacturing line for that. Did the different FDA certs that we needed, yada yada, and there's this whole thing. I was having like 11 p.m. sessions with the COVID czar and the administration and all that, really trying to make stuff for critical PPE that our country needed. So that was with the Origin side. We produced probably 2 million swabs. Didn't sell all those. Ended up being probably losing money on it, honestly. Sure. But it was a cool project. And then as a kind of side hustle, understanding that was going on, what I did is spooled up a side hustle company and produced basically like variable sizing frames for like a face shield. And so worked with a company that designed those. And then I basically kind of scaled a company, produced almost 2 million face shields for my home state, the state of Nevada, during the pandemic when they couldn't get PPE because it was sopped up by big states like New York and California. So that was kind of a feel-good moment. But what it showed me is that with zero Capex and this network of CONUS, so internal to the US and then external to the US printers, you could basically scale a company for no money. And you put different people to work. It was COVID. I had companies come to me later that maybe didn't know it was me because I kind of did it a little bit under the scenes, saying that like literally you kept our company like alive, giving us jobs, during the pandemic. So it was huge. I think it was something like 18 tractor trailer trucks worth of face shields.
That's unbelievable. So if you went to Las Vegas and gambled during COVID and the back rack dealer was wearing a face shield, Ian probably made it.
Yeah. And still to this day, there's some companies that they didn't know that I did that later came and said like, we produced 1 million parts in additive. This is like 5 years after I did it.
You're like, no.
I'll let them have it.
It's all good. Okay, so let's double tap on that because that's something that like when we started the business was really important to like maybe the speed at which we were able to design stuff, right? Yeah. Like you give this speech about like the trough of disillusionment around 3D printing.
Yeah.
And I obviously mimic it all the time because it's brilliant. Tell me a little bit about like where 3D printing was 10 years ago and then the lessons you learned at Origin and then at printing your own stuff and how that led to kind of the ideas around additive for Firestorm.
Yeah. I think the way this kind of arc went in additive is you have kind of the early adopters in FDM and SLA and different technologies. And in SLA, so stereolithography, and SLA stereolithography apparatus, which is the actual printer. The problem you have is like in the early days, they didn't have good photo blocking packages. Those are photopolymers, so they excited a certain wavelength. But outside of that wavelength, you really don't want those UV rays to damage the polymer chains. Mm-hmm. So you put in photo blocking packages. I'm also not a material scientist or a chemist, so I'm saying what I know.
He's lying about everything he says.
But so you have these parts that basically would sit on decision makers' desks over time. They got a window in the room because they're a decision maker, right?
Yep.
UV rays coming in from the outside degrade that part, and it starts crumbling on their desk.
Yep.
Now those decision makers, let's call it even 20 years ago at this point, because now I'm getting old and gray. They right, like now they're sitting and actually maybe they were like junior decision makers, right? Now they're senior decision makers, and they say 20 years ago when I worked with additive, it was shit, and for these reasons, we're not going to use it again.
Right.
And so that's kind of the fight we've had to have in additive for like the last decade. I would say is these folks that have moved into positions of power had kind of felt like the well was poisoned a little bit, and now they're just like anti-additive.
Yeah.
And it's ridiculous because every process, right? Like the first folks that used CNC machines, I'm sure they were pieces of shit, and they got mad at them. But the evolution of the technology has come so far that now I would say if you're not using additive in at least prototyping, but not even maybe like scale manufacturing leading up to high volume, you're doing a huge disservice to your company.
So, I don't think we hear it as much right now because I think we've done a lot of work over the last couple of years to like change the narrative and explain what you just said, right? Which is like, it was shitty 10, 15, 20 years ago, but times have changed. But man, how many times would you hear when we started this business? Well, I had a 3D printer in a container in Iraq or in Afghanistan, and that thing sucked, you know?
Yeah, it's the silliest thing because it kind of, what I hate about that is that it shows me that person's not curious. And you have to be curious in life. Like if you're not really looking to look around, the next ridge line, understand that everything is evolving, not everything is not standing still because you interacted with it a year ago and it sucked. Like you have to understand that typically in the world, everything is marching forward, sometimes for good and for bad. But yeah, so, we'll have naysayers say like, oh, you can't fly an additive manufactured drone. Our very first drone flew and actually it was fully polymer, no, carbon fiber spars,
no
anything.
Structures.
Yeah, flew the very first time, ended in a crash like,
that's what we do.
Should, right?
Yeah, of course.
But really showed that was possible. And why I thought that was really silly is like, in academia, et cetera, like this is not a new concept to have something additively manufactured. The way that we were going about it and being super modular and really looking at how its manufacturability and its ability to be changed by the warfighter, those were some of the new things that we were going after. But this was not like a revolutionary idea that like that polymer structures could fly. So I always thought that was kind of silly.
So talk about how like having, we can talk about a central line and then we can talk about an external next, but just having like access to the MJF systems that we use Talk a little bit about how that changes warfare, in your opinion.
Yeah, I like the idea. And then the funny thing too that I would say about like deployable manufacturing that we have, right? You have these people that kind of take a view that like, oh, that's all you guys do. So, and we think there's a problem with expeditionary additive for whatever reason.
Yeah.
The problem that I think that with people that take that viewpoint is like they're missing the whole plot. The plot is that in the thesis that we have is with our own fixed lines, with CONUS CM networks, other folks that already have our printer are smart on it and can produce parts for us like that. We call that elastic manufacturing. And then with OCONUS, outside of the US, similar contract manufacturers, and then Excel. Like that's the story. It's all of that together. But what Excel is really fantastic at is if you are at the edge, you're learning all of the lessons first. No one else out there is learning the hard lessons. And what happens is you get this disconnect between those folks learning the hard lessons and duct taping stuff together and using part B instead of part A because they ran out of part A. And on this modification cycle that happens, you lose that as those folks redeploy or whatever. And so what Excel really enables is like, let's put the keys to the car in the hands of those folks that can best kind of react to what's happening and then work with engineers back home. They don't have to solve all the problems. They're not engineers, but maybe in some cases, but they can leverage us back home as application engineers to help them build better things.
Yep. So it's basically networking technologies that like the creativity you have is what will determine you can kind of build.
Well, and like, right, as we march down this path, I mean, there's going to be, not letting too many cats out of the bag with what we want to build here, but like someone with no engineering knowledge should be able to leverage LLMs and different things to basically help them modify parts.
Yep.
So, hey, I have this fuselage section. I really need to try to fit this different payload in it. It needs a little flare out with an aerodynamic fairing, with these dimensions, create that step file for me.
Yep.
Right? Like that's what we want to enable in the future. So you shouldn't have to be, an aerospace engineer, mechanical engineer to do this, but you can leverage that. You can be Dan or anyone, right?
Yeah, for sure.
It really should be that easy.
No, so you heard it here first. Next month, we're releasing LLM powered aircraft design.
And there are great tools out there that we can already leverage, but I think what we can do is make it very purpose built for our family of systems and our partners' family of systems. And really, in doing so, build that foundation off of a bunch of really good data that we have.
Let's kind of switch gears here for a second and talk a little bit about integrations.
Mm-hmm.
You come from the commercial world. I came from the commercial world as well.
Yeah.
When you started working with defense, say DOW, right, or NSW, different segments in it.
Yeah.
Tell me about how surprised you were about how slow integrations took.
Yeah. Yeah, it's, you're talking about adding a new radio onto a system and it takes, months and months and months. And, it was a little, it was hard to hear that when you're trying to do something for the warfighter, that you're basically forcing warfighters into like, okay, well, you guys can't do it. Well, then again, back to the duct tape. I'm going to just duct tape this new radio onto my drone so I can get the freaking thing up in the air. And part of it is like the acquisitions are broken. Part of it is, the end user and the folks writing requirements are not as integrated as they should be. Mm-hmm. There's so many facets to this that are kind of broken in small ways that I know the DOW and different folks are really actively trying to fix, which is great.
Yeah.
I don't think we ever get to a point where they're entirely fixed. It's just like human nature type stuff.
Yeah.
And red tape is going to exist in some manner. But really where we can give folks, again, those keys to make modifications, to reach back to engineers to help them solve problems that they have, and it not having to be some prime somewhere that is forcing the subject that they must be involved in the integration cycle. If we can make little dents in the universe in areas there, I think we can really help the warfighter. And we've shown that we can take something, it takes weeks and weeks and weeks or months to integrate, and we can do it in a couple of days with Additive plus all of our software tools, and really focus on the warfighter.
So it sounds like you are building, how do I say this? Infrastructure layers, a manufacturing infrastructure layer, and then a software infrastructure layer.
Yeah.
If you build the layers, then how do you empower the end user to like maximize what they can get out of it? What do you think?
Well, so this ties back a couple companies ago. When I started at Segment, it was this networking and ecosystem play. And later on, I talked to some lead VCs that like missed out on those investments because they didn't focus enough on that. It's about the ecosystem that you build. So if you build a foundation and then you bring in partners to build for you, you end up having to do much less work and you can scale faster and all these things. Same thing was true at Origin, right? We built the reaction engine and then we invited all of the formulators to come in and build materials for us. If we tried to start up a whole chemistry division, et cetera, we would have been dead in the water like years before we were acquired. So here again, what we want to do is set the baseline foundational architecture. And then build things like our SDK to allow other folks to engage with us. Because basically what we want to be is the best partner in the world. You should, like, if you make a camera, if you make a radio, you should be like knocking down our door to be on our platform, because what's going to happen as that ecosystem builds out is the best tech will win. It's going to be a true market like that. And we want to enable good folks to be a revenue, like we will be a revenue engine for you if you make good stuff.
So having been selling stuff to the DoD for, I don't know, maybe a decade at this point, what's going well in the new administration, in your opinion, when it comes to either new technologies or new companies coming in? And what could they improve on?
That's a good question. I mean, I think very, very recently, and not to like toot our own horn or whatever, but like inclusion into drone dominance was really interesting for us, right? We are a enabler. So we were basically in our case, we produce frames. Drone dominance looked at, okay, how do we go in and reinvigorate the US supply chain for specifically in this case, FPVs, and really go fast using some mechanisms that isn't DIU and other things that they've kind of used in the past, using a new mechanism. And so I think we're going to see more of that. I think they are doing a good job at, basically, what are the other tools that we have, or even creating new tools like, investing in rare earth mines and stuff like that. There are a lot of different, whether you agree entirely with them or not, what I like at least is they're kind of trying out things. Again, back to that like curiosity, like what can we attempt to do to try to make things better? You might fail portions of the time and that's fine. But as long as you're like that relentless like march forward is what I want to see. And I think that at least they are like writing new chapters and new portions of the playbook, which we maybe haven't seen other folks do before. They've been, previous administrations have maybe been less aggressive.
No, for sure. I mean, I think the world's just totally changed too in the last two administrations, right?
Yeah.
As far as like near peer and like just facing the combined production of China, Iran, and Russia is like pretty daunting. You know what I mean?
I mean, you say it all the time, right? China's doing 3 million drones a year. We're doing, not even a tenth of that. It's kind of embarrassing from one perspective. The other perspective, I guess, though, is like, most of these are smaller drones, et cetera, and we're just not fighting that war. Like we haven't fought that war. Will we in the future? I don't know. I think this actually it's like a chapter in time that maybe gets flipped, and maybe some entities kind of still use this playbook, but I think ours in the future against our near peers will be a little bit of an adaptation of that. And we just have to adapt faster than the enemy. And so, is that a bunch of FPVs? Yeah, I think it'll be some of that, but I also think it'll be the more mid-tier, lower cost drones that we can make in mass.
Yep. Okay, so now we sung their praises. What are things you think, I'm Pete Hegseth. What do you basically say, hey, this is what would really help either startups or the defense industrial base? What advice would you give the admin?
Yeah, we need access to testing facilities like 10 years ago. I'd say yesterday, but it's way worse than that. Like you have a bunch of startups doing really great stuff. Not even startups, call it, even established primes.
Yeah.
You're like, we're not able to get onto bases that are, some of these bases are sitting there with nothing in the airspace for 320 days of the year. Like we need to open up access to that. Like there are American resources having those establishments.
Treat it like a national park.
Yes, we need to use them. Yeah, that's a great point. And that's underwater. We figure out areas where we can test underwater, USVs, UGVs, but like our inability to test is hobbling our entire industry. And it's making us go do things like buy our own,
test
property to be testing,
exactly.
Which is kind of egregious if you ask me, because the customer that this entire industrial base is working for has all of those facilities and could literally open them up to us.
We will be, our test range is like less than 2 hours away from our office, but we will be driving past ranges we could use to get to our hundreds of acres.
Yeah. Yeah. I drive by, Pendleton and different stuff all the time. And it's like, I see just runways out there that are kind of empty. And it like hurts my heart a little bit.
I know. It hurts mine too. Okay. That's great. That's great advice. I mean, it's something that like, I think it's a universal call from like every startup we've talked to. Even if you're building engines, you want to have a place you can go test and integrate and fly. So,
entirely.
Okay. Good advice. Hegseth, if you're listening, take Ian's thoughts into consideration. All right. Now let's talk a little bit about the role of software and you think defense companies moving forward, right?
Yeah.
The famous quote obviously is like software is eating the world. Defense is a little different, you know what I mean? For pure software plays, maybe unless you're Palantir, it's a tough business.
Yeah.
But talk about how you think software-enabled hardware is going to change not only advanced manufacturing, but warfighting in general.
Yeah. Yeah. I mean, I think obviously you have to have these folks that kind of break glass ceilings, and probably Palantir is one of those. And then, you have things like ATO, authority to operate, all these different mechanisms. We're supposed to see like reciprocity in ATO. I don't know that we've seen that yet. There are different kind of barriers that we're going to need to break to really truly go fast with software. But I think some of those barriers are being broken through. And then, if your hardware is not software defined, it should be a software defined everything at this point. I think it is, but actually speaking back to the F-22 and Bruce, I mean, I remember him telling a story about like, the F-22 being initially designed on like punch card, like computers that, it's insane, right? Like our most advanced aircraft.
Yeah, I know.
And now come to the future and like, everything's Fortran, and we're like rewriting, rebasing code and everything. And, it's a relentless march forward, I think, in software. And it's always like, right, it's continuous improvement, continuous deployment. And the government and actually industry, we don't do that well yet. We haven't had enough time deploying. So it's going to take a few reps to get better at it. Mm-hmm. But I think if you're not investing heavily in it, if you're not trying to break down the barriers of like, how do you deploy and then update software continuously, there are just problems there. So I think between like industry and government, we have to work together to make sure that we're removing red tape so we can deploy faster, with, fewer kind of hurdles in our way.
Okay. So Ian, you've talked about inquisitiveness and like kind of learning. It sounds like you're a lifelong learner. How do you do that? Do you read books? Do you watch podcasts? I mean, obviously your meme game is second to none, but like, no, tell me about how you like learn about new things and ingest new information.
Yeah. I mean, when I'm not doom scrolling recently because it's a horrible time right now, maybe that's different. No, but, I do try to. There's a few podcasts that like How I Built This, and those podcasts are super interesting. In my industry, I try to. I mean, actually, LinkedIn is a great place for that. Just trying to keep apprised of what's going on. And LinkedIn's been great because you're pulling in information from disparate sources that you'd never really look at. Everything in Ukraine, right, is super interesting. Chinese news is super interesting. What they're doing because they're able to go fast with like no red tape. It feels like, and outmaneuver us.
You seen the video that came out, I think yesterday, of the robots from last year compared to the robots from the humanoids? It is like terrifying.
Yeah, they're learning very fast.
Yeah.
So that's a big portion of it. I'm a big book on tape guy. I feel like I never have the time to actually pick up a book, but I can, listen to stuff.
Yeah.
So I try to do a lot of that. And honestly, like in Additive, what's been interesting to me is like you kind of get out there as a name, and then there's just a lot of inbound.
I bet. Yeah.
Yeah. I try to engage with them, as many of those folks as I can. My LinkedIn emails are an absolute like shit show.
Shambles. I know.
But I do try to engage with as many of those people as I can.
Here we go.
Oh, here we go. That's wild. Look at how smooth the operation is.
Unbelievable.
Holy cow. These will be at the next Beijing Olympics.
Yeah.
Beating on drums.
Exactly. We should just start running a human next to a drone to see how it goes.
I love that in the Olympics. It's like run a normal human being next to everyone. I don't know why they haven't given us that yet. That would make the Olympics so much better.
All right. So I'm a big book on tape guy too. It's incredible like how like you can just consume everything in the world now.
Yeah.
It's pretty cool.
I feel like I'm like crazy ADHD or something though, because I constantly have to be like, I got to go back because I got into my
It's about 15 to 20 minute blocks. That's all you can do, right?
Yep.
Yeah. Okay. So I guess kind of last set of questions, right? Having worked at big companies, small companies, what advice do you give people who wanted to get into the defense tech space or advanced manufacturing? You can do either or.
Yeah.
what are some good lessons for folks to learn?
Yeah, it's interesting. I look back on my career and like kind of starting in larger companies, moving to smaller startup ecosystem. Yeah. It's like, I look back and I wonder, had I gone straight into startups, would that change the like arc of my career? And I actually think like, obviously, like if looking back, every puzzle piece had to fall into place the exact way that it did. But, for really junior folks, going to a big corporation, a GA, a Lockheed, et cetera, and like really kind of learning how big companies do it well, I think is important.
Totally.
What I would suggest to those folks is some folks, the way that they work is just aligned with that really well. And you can stay there and you can have a full career at a big company. And that's a perfectly good pathway forward. Other folks that are maybe don't kind of conform as well and want to try different things out and are a little maybe more startup kind of leaning.
Yeah.
Maybe don't stay as long. And my advice is just to like learn what you can learn and get out. If you know who you are as an individual and how you want to learn and progress, you can just understand what your path should be. I think if you really kind of think deep down. And I would just suggest like don't stay longer than you should if you're that other startup type person, because what you'll kind of get like beat down by process. And that was me. I'm not like a huge like process guy. I'm a try new things out and iterate quickly and that doesn't always line up well with like the big corporation way. So just kind of understanding that about yourself would be one. So you can go to the big company first, even if you want to go to a startup, right? Learn the right lessons. And then conversely, if you go to a startup and you really find that chaos, like let's be honest, it's chaotic and it's crazy and it's stressful, and we're both grayer than we were 4 years ago.
Substantially.
So, also kind of get in and understand, hey, that's not the exact career path for me. I want to go into maybe a bigger company. And then, understand like you don't have to be in the direct OEM world. You can work at, tiered suppliers. There are lots of interesting places to work that aren't like the OEM. So don't kind of like, if you're like me, if you're an aero and you're not immediately full on designing aircraft, that's not the end of the world. Like go find a tier supplier, work on some portion of the aircraft that's interesting. And really, just keep up that curiosity outside of your lane. I think sometimes folks can have blinders on to what's out there. I know I certainly did at some points. Like Poly, at Cal Poly, I literally was like, oh, I need to get out. And my career is like, go work for Lockheed or something. That was like all I thought about, They didn't really open up. Even with like Bert Rutan, head of Scaled or founder Scaled, even with him being an alumni, saw him present multiple times at school, it didn't kind of register that path was something that I could look into.
That'd be open for you for sure. Yeah. Oh, so okay, let's maybe you can give a shout out here. Like, what are a couple good larger companies that you've seen? We have like 100 something employees now.
Yeah.
Who has a really good training process for young engineers?
Yeah. I mean, I think, so on the commercial side, I think Boeing is really good. I've seen a lot of my colleagues and folks go to Boeing and really learn great lessons and then kind of peel off and go do their own things. So I know that they train junior engineers really well. I know that SNC has some pretty good development programs where you go kind of get a little bit of exposure to a bunch of portions of the business.
Yep.
Also great. And because we're where we're at, I would say the GA pipeline of folks coming into us. Sorry, GA, for taking...
It's all right. Yeah, don't let any of the VCs learn that everyone at Anduril, Shield, and Kratos comes from GA.
But phenomenal. The folks that we've had come from GA have just been really phenomenal engineers that have learned a lot of good lessons. And it's also, I don't think, bad for GA, because what they've proven, right, is that they're creating this process and their products are longer term products. So you got to understand that engineers are going to want to go work on new stuff. GA is doing, larger scale group 5s and above. It kind of just makes sense. So, I think that they can have a lot of pride in creating the types of engineers that can go out and do other things. So, I'd see those three are high up there for me.
That's great. All right, Ian, thanks for coming today. You crushed it. I think it was awesome. Take. Thanks for listening to the Drone Wars podcast. If you liked what you heard today, please subscribe to catch all the latest insights for all things defense and geopolitics.